And I like the idea of things that are outside of our normal wood turning activities, because it shows that we have a lot of good things here. Several years ago, I read a book from an engineer that during World War II, he was an engineer supporting the armed forces. And one of the things that he pointed out is that we made a lot of advances during World War II in technology from people working in this area, taking those ideas and applying them over there. And there's a lot of examples of that, and I see some of it here. Now, my demonstration tonight, if it's all right if I just go ahead and go into it. If you look at this, these items here, I'll pass them around. These are all done on the lathe using vacuum systems. I'm going to start working or showing you some things about how to use a vacuum system and see how far we go. Now, turns out that I wrote some articles on vacuum chucking published in American Woodturner, and I've got 3 of them, and I made the mistake of reading them the other day. So this one's February 2011, October 2014, and June of 2012. Well, I stopped writing because my wife got ill, and I took care of her, didn't have time to writing. And going back and looking at those, I need to get back busy and fill in the gaps. And 2 of those articles are primarily about how to make sure your vacuum system itself is working correctly. And tonight I'm going to give you an overview of that. And also I want to show you a little bit about how to actually use it. And the 3rd article is on what I call a conformal vacuum chuck. And talking with Dave Landers, a month or 2 ago, he turned some stuff. And I asked him about, did he know about my conformal vacuum chuck? Because he didn't use it doing what he did. And he was very polite about it. But when I read the article, that article is obsolete. I don't do it that way anymore. I have learned a lot of things that I have not documented, and I don't think that a lot of you know about them. When I first started doing vacuum chucking, I looked at it, hey, it's too expensive. I can't do that, I can't afford it. And at one of our symposiums, there was a vendor there that was selling vacuum systems. And all of a sudden, instead of paying $800 for a vacuum chuck, I could get a whole system for about between $250 and $350, something like that. So I built up a vacuum system. And once it was built, it says, oh, it's running. How well does it work? Well, I worked for 30 years in industry, and whenever we built something, we always turn around and test it, see how well it works. And there wasn't anything to tell me how to test it to find out how well it works. So I proceeded to figure out how to do that, and that's what generated several of those articles. And we're going to talk a little bit about that tonight. And I encourage you to ask questions. If I say something you don't understand what I said, or you don't know why I said it, ask. If you don't know why I'm doing something, you need to know it. Okay, what is a vacuum system? Well, let's start off. I want to see a show of hands. How many of you use vacuum? Okay, how are you using it? Well, the thing that I'm concerned about, there were some people who did not hold up their hands. And I'm wondering what they're thinking about. Who was it that didn't hold up their hand? Do you have a vacuum cleaner at home? Yeah. Okay, you use vacuum. Okay? How many of you ever drank with a straw? Nobody? Okay, how does that liquid flow up the straw into your mouth? It's a vacuum. So you have to ask yourself, how does vacuum work? Does it pull that liquid up that straw? How many think that the vacuum pulls the liquid up that straw? Okay. Those of you who did not hold up your hand, you must think it's a loaded question. Well, how does that liquid come up that straw? Okay, what you're doing is you're creating lower pressure in your mouth than outside. And air pressure pushes down on that liquid and pushes it up that straw into your mouth. So when we're looking at vacuum systems, what we're doing, we've got a vacuum pump over here. We've got a filter, and it pulls the air through this pipe and pushes it out. Then over here, where you're putting your piece of wood on that vacuum chuck, is the air is pushing against that, pushing the bowl against that, or whatever you're turning, against that vacuum chuck. So the air is pushing on it. Now, how much pressure can you get from that? The idea? What? It depends upon your altitude, and it depends upon the weather. Let's see. Air pressure right now in this room is 24.969 inches of mercury. My watch has an application on it that tells me what the air pressure is. Now, if you watch the weather tonight, they talk about high pressure areas, low pressure areas, but they don't tell you what the actual air pressure is anymore. They used to when I was growing up. And you have to be careful with that, because when the Weather Service is working with air pressure, they normalize it all to sea level. And we're not at sea level last time I checked. We're somewhere around 5,000 feet, plus or minus. How many of you here have a iPhone made by Apple? Okay. You have on your iPhone built-in applications that will measure a hell of a lot of things. Air pressure. I can pull out my iPhone and I can measure the size of that screen right there. It can look at it and I can measure the size of that screen. They've got a lot of sensors in there that most people don't care about. But engineers are crazy. We're interested in those things. And so we're going to be talking about some of those things tonight. Now, so the vacuum pump creates, or it pulls, or it removes the air, let's put it that way. It removes the air, and the air atmosphere tries to push down through here and replace the air that the vacuum pump is pulling out. Now, another question. How many of you have air compressors in your shop? Okay, those of you who have air compressors, how many of those have a pressure tank on it? Okay, what's the purpose of that pressure tank? What? Okay, it's a reservoir. It's a reservoir, and if you just had the pump itself, it wouldn't supply enough air to do what you need to do. So you put that tank on there, and that acts as a reservoir so that you can draw on that and do things quicker. An example, you've probably seen these ads for these little battery-operated air compressors you carry in your car so you can pump up your tire. Those things will take 10, 15 minutes to pump up your tire because they do not have the reservoir. Okay, but we're talking about our vacuum system. This system over here down the bottom is kind of hid, but I've got a couple 4-inch pieces of pipe in there that I built tank. It's a reservoir. That's what I'm doing right here. Now I'll do two things for you. Question? Okay, that reservoir acts as a vacuum reservoir to give you more capacity than your pump can provide by itself. And I don't know if I can demonstrate it or not, but basically what happens with most people is they'll put their item up against the vacuum chuck, turn on the vacuum pump, and let it soak down. Okay, I don't do that. I've got this tank down here, which acts as a reservoir, and I've got an isolation valve up here. And so I'll have the pump running, and then I will open up the isolation valve, and I'll hit that thing real hard. That allows us to suck that bowl on there quicker, and in some cases it will attach the bowl where it will not if you just do it the old-fashioned way of just turning the pump off and on, because it hits it real quick. Have any of you ever had power failure in your shop? Anybody? Okay, that's another reason for having that reservoir. If you're sitting here turning and you blow a fuse or a circuit breaker or have a power go out, your lights will go out, and with the reservoir, it gives you time to get out of the way before you lose your vacuum and get out and get hit with the thing flying off. So there's several things going on there. Now, if you can get a zoom in on this is my system over here. This is a pump, obviously. It's kind of see what that is. This is a piston pump, 2 pistons. They're in series, so it gives you a little more capacity than a single piston. Are there other kinds of vacuum pumps? What kind are there? Louder. Venturi. Okay, there you're taking compressed air, running it through an orifice and pulling air, right? Okay. Okay. So what? Okay, rotary vane. Okay. Diaphragm. The first vacuum pump I had was a diaphragm pump. I've got a rotary vane at home that somebody gave to me. Somebody, I think I heard the word oil. This one is oilless. It does not have any oil in it. It has some sort of a plastic rings, sort of like piston rings, that work very well, do not require lubrication. You don't have the workload on this like you have on a regular air compressor. So here's the pump, and coming out of the pump, we go through a filter. Then the filter comes down here and comes out to a manifold. And this manifold, this valve here is blocked off. I was doing some testing and so forth. So that's kind of non-functional. This isolation valve is one that's not on a lot of vacuum systems. Then I've got a vacuum gauge up here. Then I've got a bleeder valve up here so I can bleed off the vacuum. If you're trying to take something off and the vacuum's holding it, you don't want to wait 5-10 minutes for it to release itself. And then that comes down and goes to my vacuum adapter. Now, I have an extra gauge down here, then I've got a gauge over here so you can see what I'm talking about. Hopefully you can see that. Now that gauge, if I remember correctly, about 20 years ago when I bought it, that one cost me somewhere around $30. These other little gauges, they're around $5 a piece. Ever hear the phrase, you get what you pay for? I believe the number on that one. These little gauges, they don't even agree with each other. So I've had some situations like that show up. So let's, we got the system set here. Okay, now down here I've got another valve. It's off right now. Let's turn it on. This valve goes through a hose. Down here I've got my reservoir pump. It's kind of hidden. If you go into the AAW and look at those pictures, in there in that article, it shows that down there. Any questions so far? Okay. Now, I dug this piece of wood out this morning. It was hadn't been cured as long as I really would have liked, but cured enough that it was rough turned. I went ahead and finished turning it to this level. And so I want to show you how to mount this. And you're going to help me with that. So let's take this off. There we go. Okay. Now, I'm going to mount a vacuum chuck on there. This is not commercial made. I made it. I probably got $8-10 invested in this plus my labor. That's one of the things I need to write up an article on, is how to make these things. Basically, I'm using Trex down here and drilled it, and I tapped it so that I can screw it onto the spindle. And I recessed a groove in here, and I filled it with silicone, and I put screws in it to hold it mechanically. So I'm using the silicone to seal it, but using the screws to hold it. And this has been reused a little bit, so there's a couple of screws in there that don't make any sense if you're thinking about regular usage. This, I tapped that. I had a gauge put on there. I was doing some studies in one of the articles I wrote where I was measuring the vacuum in here versus elsewhere. Okay, so we're going to mount this. How many have ever done any plumbing at home? Okay. Did you do anything to seal the gauge, the threads? What'd you use? Teflon tape, okay. That's what I'm using here, because I want to seal this. And one of the things that I found out when I was doing some research, I was starting out on this stuff, nobody sealed anything. They just let it go. So I'm sealing it. And generally I put about 3 layers on here. And when I get through and I take my vacuum chuck off, I leave it on. I don't worry about taking it off. When I put my scroll chuck on there, off and on there a couple times, that takes care of it. Now I'll screw this on there. Okay, now I want to know how well it's going to work. How do I do that? Say again? Turn it on with the flat plate on. Okay. Think this might work? Okay. Okay, so I'm going to put this on here. Well, wait a minute. This is the way I do it at home. I turn this close this isolation valve, and I turn it on. And if you can see the gauges, this one is an indication of the vacuum that the pump is pulling. And this shows the gauge for everything else. And that should, ideally, that one and this one should be the same as well as that one. And they all read 0 now, don't they? That's good. Okay, now I'm going to put this on here. Wait a minute. I want a volunteer to put this on. Come on, I want a volunteer. Somebody, come on. Okay, just put your hand right there. Just flat. Okay, you got it? Ready? and turn that on. Feel anything? You didn't feel it concave a little bit?
It's slightly right in the middle.
Yeah, it sucks down a little bit in the middle. So it's got some pressure on there. Okay, this diameter of this chuck is 4.8 inches about, which is about 18 square inches. So you take that and you multiply it times the pressure. So the pressure is, what's that over there read? Look like about 23.5. So take 23.5. Who's got a calculator on their phone? 23.5 times the area, 18.1, and then multiply that times 0.5. Who's doing it? It's a couple hundred pounds. And
215.
what was that?
215.
215. Okay, 215 pounds pushing that way. That's a lot. I'm glad to say that's more than I weigh. Okay, now that's a lot of weight, a lot of pressure on there. So what would it take for us to get this off of here right now? Well, without by turning it off. Turning it off is cheating right now. Okay, so that's on there pretty solid. Now, what kind of forces are going to be on our vacuum chuck when we put this guy on there? Well, it depends on how much it leaks. Okay, but right now, to take that off, we'll have to, if we pull on the edge, it's going to break the seal and then we can get it off. If we pull straight off evenly, we're going to have to pull hard, real hard. What about sideways? What if I put a pair of pliers on here and just pull this way? How much? How much force is it going to take? Ever hear of the coefficient of friction? So that's all it's holding this thing on here right now if I pull sideways. It's friction. And friction it's a multiplier. You can either say it's zero, which would get, if you oil your engine, you have really low friction in your engine. Or if you have something sticky, like this foam I've got on here, then it's a little bit higher. But I could pull on that, works real well. Now, when you test your vacuum chuck like this, be careful. Make sure you use something that will tolerate the force, because like this right here, I can feel that. You felt it. It's caved in there right now. I had a friend that was working with me, and he put his vacuum system together, and he was wanting to test it. He did not have an aluminum plate. So he went hunting. He went up in the kitchen, and he found this nice little saucer. So that ought to work. He took it down there and put it on there, turned on the vacuum, and it shattered. His wife wasn't very happy. So it does have a force on it, and it can do a lot. Now, when we're turning, what kind of forces is our chuck going, or is our piece going to feel? I'm going to mount this on there a little bit so you can simulate taking off that tenon. What kind of forces are going to be on that? It's called torque. We're going to take our gouge, or you're going to take your gouge and you're going to be cutting that tenon off of there. And you want to be careful about the torsion that you put on there, because that'll take it right on off. And the techniques you use when you do that makes a difference. Okay, let's. What's the question?
Before we turn off, could you talk about the two gauges again right now since they're on?
Okay. This gauge is the vacuum coming from the pump itself. This one is the manifold, which is going down here, and I've got an isolation valve between them. Say again? Okay, now, I'm doing a self-test. Right now we know that it pulls a vacuum, and it's holding that on there. Now, it's not telling me how much leakage I've got. What we know is the leakage is less than the pump is capable of handling. But it doesn't tell us that there's zero leakage. Ideally, from here down is zero leakage, because this guy here is going to leak like mad. I want to take all my capacity and reserve it for holding that bowl on there. Okay. Now, first time I did this test, my aluminum plate fell off in 15 seconds. And I learned how to find out where my leaks were. And the next time I did it, I got to where it stay on there for 15 minutes. So let's close our isolation valve and see what happens. Not moving very fast, is it? It's going pretty slow. That's going to stay on there for probably 10 minutes maybe. I don't want to wait that long. So we have another valve up here called the bleeder valve. And so I'm going to turn that. Makes a difference, doesn't it? Okay, so we know our system is working well from here down. Does not have any leaks. Now, the other thing that I discovered, I was working at my shop, and for some reason or other, I left, and it was basically that condition like that. And I came back, I looked at the things, there's nothing on there. Why is that thing reading? Well, it's reading about, 2 inches of mercury now. It was reading around 6 or 7 inches of mercury that time. And I said, well, there's nothing on the chuck. How come it's reading so high? And as a result of that, I figured out the losses in the system. Several changes I made. One of the big ones is I went from a 1/4 inch hose to 3/8 inch hose. So I learned how to remove the barriers, sometimes called the critical orifice. So I learned how to remove that, and I got a lot more performance out of it. And those are documented, those things are documented in the 2 articles I wrote. So let's close this valve. So it's got a vacuum. The pump is generating a vacuum, and we're ready to mount this on there. And we want it mounted so that we can have it not crooked. We want it straight. So how do we do that? This help? So this will work. This is one technique. I've got about 4 listed. Need to lubricate that. Okay. So that should hold it on there and get it on there straight. And I can line it up, and I can take my this thing got a lock on the spindle. Where's the spindle lock on this thing? Oh, looks like that guy. Well, what's that? Push, pull, or just twist? Go the other way. Here, unscrew you.
Sorry.
Oh, locked. Okay. Okay, I see what they're doing.
Yep.
There, it should be unlocked. I don't know why it's turning so hard. Oh, because we don't have a live center duct here, do we? Okay, that's why it's turning hard. Okay, so that should get it positioned. Let's turn the vacuum on and see what happens. Ah, something isn't working. What is it? Where's our leak? Okay, something on this bowl is leaking. How do I fix that? Tighten it up a little bit, maybe? Well, that didn't do it. Any other ideas? What's that? There's a couple of possibilities. Harry's saying that wrap the bowl. Bowls will leak. Okay. Stole this out of the kitchen. What's that? I'll get the. Let's try wrapping it and see what happens. Okay, let's turn the vacuum on so we can let it help us. And no, that wasn't enough. Oh, it's not covered over there. Well, that didn't work. Sometimes that works. There's other ways of doing it also. Question is the leak here or is it down there at the gasket? Know what this stuff is? Oh, cellular foam. Okay. Now, I could put that in there and help our gasket a little bit, but I got to do it in such a way that the vacuum can get to the bolt. So I'm going to cut a hole in the middle. Let's see if that helps. Say again?
Did you show the hole on the top of it?
Okay. If this makes a nice gasket or seal on there, then I need the hole so that the vacuum can touch the bolt. So let's see if that works. Huh. Going up. So the gauge is going up a little bit. So we're making progress. Well, that's enough that we could turn off the tenon right now. It's not perfect, but it's usable. Okay, let's take this off.
Came down a little bit.
It's because it didn't have a good enough vacuum, did it? The vacuum went up more though, didn't it? Okay, now we can back this off a little bit. We don't want to turn it off completely. But we back off the vacuum, and that allows us to adjust it. Let me get the chuck off of there. Get it out of the way. Now, if we had a good vacuum seal, that would have taken care of it, wouldn't it? Now, there it is.
What would you want that top gauge?
What's that?
What would you like that top gauge to be at for the vacuum?
This one? Ideally, I'd like for it to be equal to this one over here. But I backed it off a little bit so that I could make some adjustments. So I could bring it around. Now I've got, when I turned my tenon, I left a hole, if you can see it down here. I left the center point from my live center from when I turned the tenon originally. So I could use that as a reference to the center. At home, I've got a mallet that I use. I don't have it with me. Okay, now I've got that centered now. Pulled off again, didn't it? Okay. I don't know about you guys, but when I have a demonstrator making a demonstration, when they have problems, you learn more. Okay, I'm tightening it up more this time, so it will have a better chance of holding it. Now let's turn it on. Okay, so we just saw two different ways of centering it. Okay, and you can wrap that around and you can find out a little better about where there are leaks and cracks, so you can get that good enough that you can hold it, and that's good enough to hold it for turning off the tenon and sanding. And the other thing that will happen is when you start sanding, you see how this is kind of gripping on the surface? This is silver maple, spalted silver maple. So it's lost a lot of its integrity. It leaks a lot more than standard maple would that has not been spalted. What happened is I wrapped it with saran wrap and put it on a shelf and forgot about it. So it sat on the shelf in my storage building for a year and a half, 2 years. And I walked out there. What's that black block of wood? That block of wood is completely black when I found it. And this is one of the things I pulled out of it. Okay. That's two ways. Can you think of another way to center it? Okay, the way that you normally find the center of something is you'll use some sort of a marking gauge on your round object. And you could use this to, if the tenon did not have it marked, use something like this to mark it. There's another way. There it is. I'm a toolaholic. Now, assuming that you still had your stuff on there and this was not in there, okay? Now, in the case where you turn that tenon and did not leave that center mark in your tenon, okay, your bowl is sitting there, this is still mounted on it. Now you can take something like this. It's got a hole in it, it fits there. And then you got a punch. This punch has a center on it. You can take that and you can come down and you can make a hole or dent in the center of your tenon. In a way, that is better than the one that you got from the original turning. If you think about it, wood compresses. And when you do like I do, and you take that chuck and you crank that thing down as tight as you can, it distorts. So by using this technique, it's going to be more accurate than using the original one. But I seldom use this technique. I use the original one most of the time. So there's 4 different ways that you can use to center this thing to get it started. And then at this point, you can go ahead and start turning that off. And when you get it turned off, you can sand it and finish it up. If you're very careful, take that tail center off at the very last minute, you can get by with that. I would not want to do very much turning without the tailstock holding it though. I wouldn't trust it that much. Another thing I want to point out to you, when you're turning this, I don't know if you can see it or not, but the grain on this is this way. It's up and down right across perpendicular to the bedways. When you're turning that, when you're turning in general, weren't we told to always turn downhill? You go downhill, you do not go against the grain. Well, if you stop and think about it, if you're turning that tenon off using just going there like that, hey, you're going to be turning against the grain in part time when it comes around. So be careful. That's a lot of extra torque on this thing, and torque will take it right on off of that chuck. What I typically do on this is I will come in this way. It cuts easier, and it doesn't cause as much torque. And it stays on, holds on a lot better. Any questions so far? Well, let's talk about something different, but still using vacuum. Yes, what's your question?
You're using a 4 and a quarter, 4.5 PVC for your chamber, right? What if you shrunk that down to 3 inches and it went all the way to the bottom of the bowl? Would that give you a more pressure, more mercury?
Okay. The question is, if I use a smaller diameter chuck, like this one, maybe? It'd be worth a try to see what happens. Now, the surface area will be smaller, so with the same level of leakage, it would actually have less force, but it may seal better and get better leakage, or less leakage. That's better. So it'd be less leakage. Now, the thing of it is, if you went down to, let's say, 2 inches, you'd even have less force. Question?
Comment. If the surface area of that circle is pulling against a flat bottom, it's going to have more pressure than if it's on the side because of the smaller surface area of just the outer rim.
Not quite correct. What makes the difference, if you have a flat piece on there, straight flat on there, then and for the same vacuum, the larger the diameter, the more force you have. Okay? The thing that complicates it pull this off for it. Okay, the thing that complicates it is the leakage of this. The thing that may happen is it goes down in there and it has less area for leakage. So the pressure may go up, the vacuum may go up, not the pressure of the vacuum. The vacuum may go up, which yields more force. So it's worth trying, and it's a situational ethics. It's going to depend upon the situation. But in general, the larger the diameter, the more force you are capable of. Not necessarily the more force you will have. It depends on how good of a leakage that you wind up with. Now, what I'm going to do is show you a I'm going to put a different system on here. Now, incidentally, if you look at the things I have here, this has got trucks and a PVC body. The gasket material on here is craft foam, bought down Hobby Lobby, 8 by 12 sheet, 99 cents. So it's effective, it works, and you can overlap it about 1/16 of an inch and it still works okay without any problems. Now, this chuck is made entirely out of wood. So I made the chuck and I sealed it and so forth. So it's entirely out of wood, and I'm going to put another layer of tape on there. I may need it, may not need it. But typically when I change chucks, it has compromised the seal a little bit. Plus this one is worn a little bit, so it fits a little bit differently. But that should be a decent seal. Okay, got that released. Let's find out how good our seal is. Now this being wood body, it's going to leak more. Let's see how bad it is. Well, it's doing pretty good now. Okay, got a piece of wood, 5/8 to 3/4 inch thick. I've got a template. We're going to make us a coaster. And let's see, does it leak very much? It's doing pretty good. Doing better here than it did last night. Okay. Now, one side of this has been sanded a little bit better than the other. So what I'm going to do, I'm going to bring this up and put that on there. And I've got the center of my template marked. And I'm using a spring-loaded center pin. So the spring-loaded center pin is tolerant of, it doesn't tear up my template that much. Okay, and I just got that spring-loaded pressure on there, and okay, so now I can close it. Well, I don't see it. I thought I had a shorter tool rest. We'll go use this one. Okay. And we've got good vacuum on there and everything. So by using the template, if I do it correctly, always rotate things before you turn on the lathe. Make sure it clears, so it clears. And let's see, there it is. You guys have all heard of bevel rubbing, haven't you? Okay, if you rub the bevel against your template, you don't damage your template. So let's see how fast this thing goes. I always put my hands on the lathe someplace so I can measure, feel the amount of vibration I've got. Okay. Okay, I've got my diameter. How many have you used? How many have you used templates before? 2 or 3? Okay. I've got my vacuum on, so I can go ahead and remove the template out and get it out of the way so I can round off the edges. Got your face shield on? Okay, we just finished the bottom of our coaster. So we can turn it over and do the top side. And okay, now the template is properly centered because it's on the center pin, and I can move that into proper positions just by pushing. And it's important that you don't forget to turn the vacuum back on. I have been known to make that mistake. I have a small mallet, wood mallet at home that I use for making adjustments like this. Okay. So now the vacuum is going, it's holding nicely. Any questions so far? Anybody bored? Okay, that's good. Now you notice I'm starting from the inside. By starting at the inside, it creates little torque, and it's a little friendlier to a thing. I'm using not bevel rubbing, sort of like a scraping action. Getting a straight edge. I can take this and put it in there and take a ruler, and I can determine how deep I am, and that's about the right depth, maybe a little bit deeper depending on what your individual preferences are. And I just need to even it out a little bit. Not perfect, but you get the idea. Here's another one I turned the other night. Questions?
Yes, sir. On your chucker right there, what's the white stuff that you're using for the seal? Is it just
This?
Yes, sir.
This stuff.
Scrap foam.
This is craft foam. I bought it at Hobby Lobby. Looked the other night, and they've got it 8 by 12 sheets for 99 cents. It's got adhesive back on it. So to put this, matter of fact, I put this gasket on there last night, and I took a strip of foam, just took a straight edge and a knife and cut a strip down there 1.5 inches wide. There is a reference line. It's covered up right now, but there's a reference line on there. Oh, I can see a little bit of it here. And I just took that strip and wrapped it around there till it came around to where it overlapped. And I try to keep the overlap 1/8 of an inch or less. It'll still seal that way. Then I take a pair of scissors, because that stuff's sticking out. Take a pair of scissors and cut in there, then folded it down and made it stick. And I'm always trying to find ways of making it stick better, because one of the problems is that, well, if you look at these, if you look at it, you see little dents around the side. It looks an awful lot like clothespins were on there. So without a little bit of help, These guys inside will spring back up. This is the natural springiness of the foam. So, what is it, about 50 cents for this gasket? 50 cents for that one. I was looking on Robust Lays the other night, get a reference point, and they sell vacuum systems. They got a lot of stuff that are available, but you may want their vacuum pump. You may want their rotary valve, but their vacuum chucks start at $90. I think that's a 4-inch one, on up to 120. They have a rotary adapter a lot like the one I've got here. It will fit their lathes, and it'll also fit Powermatic. That one is designed for the Powermatic because of the bore in the spindle. I've got a Vic Mark at home, and the guy that I was working with when I met at one of our symposiums, it was JT Turning Tools out of Omaha, and I don't think he's around anymore. But I measured the size of the bore in my spindle, and he made this one specifically for me. That was just like this, just a little bit different diameter. It's got O-rings on there. I've never replaced these O-rings, but I do use a white lithium grease. I don't know where I got this. I've had it forever, it seems like. So I just took my finger and put some of that white lithium grease on the O-rings and shoved that into the spindle, and it works pretty good. And that's the type of vacuum gauge or vacuum adapter that Robust sends, and it will fit Powermatics or anything, and Robust obviously, because they have the same size bore through the spindle. One Way sells a vacuum adapter that fits theirs, and it screws onto the outboard end. And I've got one setting over there that I bought from them to get an idea of what it looks like. The thing that got me about One Way is that they did not have any instructions telling you to seal the threads. And I guess you say that the impression I had was that the leakage is going to be low enough that they didn't worry about it. I'm a nut. I worry about it. I want to reserve all that leakage for my what? Oh, pass it around if you want to. Just as long as I get it back. Oh shoot, that was probably 15 years ago. My memory's not that good. Probably polyurethane or something like that. If I were doing it right now, I would say I'd probably use polyurethane or something of that nature, and I'd use multiple coats to seal it with. There's another way also. Here's what's kind of crazy. Got a faceplate on the bottom. So I got a faceplate, then I screwed that into a wooden block, and I've got silicone sealant between it and the wood. This one doesn't look like it's been sealed, but what the Sam Hill would that crazy thing be used for? Any ideas? A vase, yeah. You notice the tape on here. That's to adjust the diameter of this to fit the hole of the vase. I had a bunch of them I was making for Christmas presents, and even though I used the same bit to drill all of them, that inside diameter is slightly different a little bit. Yeah, it depends upon the kind of wood, and I used a variety of wood because you're giving out gifts, you want it to be different. Each one is unique. So Now I've got that foam down here again, that same foam I used over there. So I put my vase down over here and it held it in place, and it allowed me to finish off the base nicely. So this is another way of doing it, is to use a faceplate and seal it. Just as long as I get it back, I'll be happy. Question?
Is there a number that you're looking for on negative pressure that feels safe? Could you repeat the question so people
Okay, you're wanting to know what vacuum level
Correct.
I need to have it feel safe. Now on my gauge, I blocked everything off, and I put a little mark right there as to where the needle was, and I did another one down here, and that allowed me to have a reference point. Now, right now, the vacuum on the pump side is higher than when I marked it. So if I know that the vacuum gets up at least to this mark that I put on there, then that tells me that the leakage is lower than what the pump can pull out. And so that gives me some confidence there. Now, when I've got something mounted out here and the gauge starts coming down, I start getting more and more nervous. If it's down around, let's say, between 5 and 10, if I've got the tailstock on it and holding it, then if I'm very careful, take very light cuts, I'm confident that I can do it. If the tailstock's not on there, I'm not going to do anything more than just sanding. That's another thing I like to do, is when I'm sanding something, I can put it on here with a vacuum chuck, and it may not be a perfect seal, but it makes it convenient for sanding the thing. If I have down here and I have to do this, it makes it awkward. But if it's sitting up here, it's nice and steady. I can rotate it. I can get different things. And in a lot of cases, I'll use a air pressure operated 2-inch orbital sander that I use. The one that I'm using right now, I bought from Woodcraft when I was working here, and I think it was running somewhere around 115, 120 bucks, something like that. But it's nice. I like what it does. It's about the right size. It's got an angle on it. I can do things, and it's a random orbital as opposed to using a 2-inch disc on a drill. Now, if I have a 2-inch disc on a drill, I can do some nice sanding, but I have to be very careful or I'll do some gouging. And the way I look at it, I was cleaning up I never make errors, but there were some gouges in there, dents in the wood, and I was using a 2-inch 80 grit sanding on the drill. It was very aggressive. And I finished that up and I transferred over to the 2-inch random orbital sander, same disc, and boy, it sanded a lot better, and that type of thing. So it's kind of some of the things I'm running into. I'll pass this one around and let you look at it. You might ask, why did he leave that thing square? Okay, first of all, that's made for my other lathe. The other lathe has a 1-inch spindle on it, so that's different. Also, notice on the bottom, Harry, hold it up. You'll see there's a space around that hole that's flat. Okay, because the texture on that thing is not flat, and when you put it on here, you want it to hold. And if you look at your spindle, let me get this thing off so you can see it. If you look at your spindle, it's got a flat spot on it. So this area right here around the spindle, that is flat and perpendicular to this. That is used to register everything that you screw on there. That's your scroll chuck, your vacuum chucks, anything else that you screw on there. You want a flat spot on your unit, on your chuck, so that it will register there and be flat. You don't want it to wobble. Make sense? Other questions? Now you notice that I got a rubber band around there. Anybody idea why? What?
So you can remember?
No, there's another reason.
Flip it so you can remember?
Well, what will happen with these things, that foam right now is kind of flat, isn't it? You bend it over, it wants to straighten out. So on all of these things, when I'm storing them, matter of fact, the one that's floating around that he's got right now, you'll see some dents in the perimeter. Those are for having clothespins on it. Those clothespins hold it in place while it's in storage. I don't have any problem with it coming loose while I'm using it, but you set it on the shelf for 2 or 3 weeks and come back and it's sticking its head up again. So putting those clothespins on there, and then the rubber band around the outside is a similar type thing. I don't have as much trouble with the outside as I do with the inside. But also on the inside, it doesn't affect it very much. Okay, there's a reason for making it square. One is I just didn't turn it off. But the other thing, let me pull this out. See the holes in there? Those are threaded, okay? One of the articles I wrote is called a conformal vacuum chuck. And the idea of it is that if I'm turning something, could you hand me that one right there? Yeah. I was at one of our symposiums, and there's a guy selling some burls, and it had 3 knobs on it. And that click, that's like a 3-legged stool. Okay, so the idea of it is I want to make a bowl out of that without destroying any of this. So the article that I've got a copy of it over here, called Conformal Vacuum Chucking. The idea of it is you take something like this. It's a bag. This looks like a pair of old jeans I cut a leg off of. And I sewed up part of it, and I've got rice in there. Not a whole lot, but some. And the idea of it is that you take that down in there and work it down in there. And then you take, this is a film. It's similar to that saran wrap or whatever that is, Glad wrap. It's similar to that, a little bit heavier duty, and it's easier to handle. And office supply stores sell this. What's that? I don't know what it's actually called, but it was originally about that big around. And you can take this and wrap it around. You can put a cover over this. You wrap, like I was doing earlier, trying to seal that thing. You make it tight around here and leave it loose on top. Okay, and then this is a little bit big for this particular chuck. I got another one at home that's smaller, but you put it down in there and you get it oriented the way you want it with that saran wrap on it, and it's on the chuck, on the spindle. You pull a vacuum on that, and that rice gets rock hard. It's rock hard, and it is steady and stable. And if you look at that article, it will give you the idea of what's going on. But that article is also obsolete because I did not use this bag, and while it's in there, and you got your tailstock holding it in place, you can turn the outside, you can turn the rim, but you can't hollow out the middle. So what I had done with the original article is I said, okay, I forgot what it's called, but there's a technique that we use for we can hold items, hold a ring on it. Donut chuck, okay. So if I could put this on there, I could turn out the middle. And that article, well, I consider it obsolete, but that article had the top layer of film here. Instead of going over the top, it came up and went out. Okay, it went out, let's see. Okay, it goes across. Instead of going down the side, it goes out. You put your object on there and bring it up and collect it up here together. Then you run that through the middle of your ring and then pull it back down around the outside. And when you pull a vacuum on it, it pulls down on this, a couple 100 pounds of force, and holds it in place. That's the way I did it originally. And I think that's obsolete. I got a better way of doing it now. The way I'm doing it now is that I do not, once I put that film on here, I leave it. I don't take it off. The other problem is, this is not a good example because this is too small for this particular piece, but you realize that moves around. Getting it centered and so forth the way you want, it's kind of difficult. So what I came up with, when I do it now, I take my block, I take it over to the drill press, and I get it just exactly the way I want it. I drill a hole down what I consider the middle and perpendicular to the surface that I want. Then I screw in a lag bolt, cut the top off of it. I screw that in there. So that gives me a reference as to where the center is and the plane that I want it. Then I walk over to the lathe where I've got this thing set up correctly. I put it on there. That's sticking up there. I took the center pin out of this live center, and now I can control the darn thing. The way I was doing it before, it was very difficult to maintain orientation. But this way I can orient it. That's the article I need to write. And since that's in here, and then that allows me to turn the outside, but I can't finish up the middle. So then I come back, and I don't even have to take the tailstock off. I just leave it there. What I can do is I can slip this over, and I put these on here like so. Okay, and now I need to hold those in place, and someplace, yeah, there they are. I could take something like this and run it down there and screw it in, and I can provide the force down there. So I don't have to reconfigure by anything. The tailstock's still there, and I can put these on there and I can hold it in place, donut chuck. And then once I've got it held in place, I do not take the vacuum off. So I still maintain that negative space that's captured this. And then I put enough of these rods around there and suck it down. Then I take the live center out and I can finish the thing up. Hey, I see a head nodding. Makes sense then. Now, the other way people have been doing things like this, David Nittman and I were talking about it one time. He did some things similar to this, but he would turn a bowl and put his burl inside the bowl and fasten it in place with hot melt glue. And then he'd do his turning. And then after he finished, he takes it out, and he has to take all that hot melt glue off. I understand that alcohol helps take hot melt glue off, but this avoids that. It just makes it, to me, it's a lot easier and faster.
Got about 15 minutes, John.
15 minutes? Well, a lot depends on what kind of questions you guys have got. I got one more thing I would really like to show you. I don't want to steal anybody's thunder, but there's been some programs on the internet where they are doing fancy turning, offset decorative work. If you look at the stuff that's setting over there, all those things are setting over there. I did those using vacuum chucking systems. And not in all cases is the vacuum applied directly to the object, but I'm using vacuum to assist me to do some of that stuff. Let me show you how I did that. Okay, first thing we do, we've got to put our vacuum chuck back on there. And you notice the tape is deteriorated. This stuff, I need to go back down to Harbor Freight. I think they got packages of 10 rolls at a time or something like that. It may not be the best in the world, but it's like anything that you buy at some of these different sources, online and in person. You get what you pay for. If you're real careful, you can get some good stuff at reasonable prices. There it is. Okay, put my vacuum chuck back on there. And if you look at those items that are sitting over there, there's a trivet over there that's got fancy grooves in it on both sides, and they go all the way through. So they say use vacuum systems on that. The vacuum with a big hole like that, I cheated. I didn't use vacuum directly on that. I used vacuum to assist. So, all right, where did I put it? There it is. So I'm going to take this disc. Got to do a self-test. Got to make sure the thing holds. What happened? That's still holding a vacuum. The motor does not want to start with that load on. I got to get that vacuum off of there before I can start the motor. Another side light. I bought I won't tell you who I bought it from, but I bought an inexpensive vacuum pump that was advertised to use for automotive air conditioning. And it was a rotary vacuum pump, and it used oil in it. And I took it home and I tried it out, and boy, it worked great. It really pulled a nice vacuum. The problem of it was that all the oil was gone in about 2 hours. I'm not sure exactly the cause, but my guess is, and it's strictly a guess, that the amount of air that was going through it is much more than what you'd have with an air conditioning system. And that may have been the cause, or it may have been a defective pump. I don't know. Anyway, I took it back and they refunded it. So, okay. I have zero vacuum, so now I feel comfortable. Let's just open that up, and we're going to pull a vacuum directly, and you'll see how slow it goes up. If I had this isolation valve closed and had a vacuum on the pump, on the system with the reservoir, that would go up a lot faster. And sometimes, depending upon what you're working with, we saw the problems we had with that bowl. Sometimes pulling the vacuum quickly, it will seal. If you're doing it slowly, it will not seal. And we turn it off. Oh, it's holding nicely, so we're okay. Okay, now I'm going to put this up here. I'm going to mount that. Okay, so now I've got something I can work with. Someplace here. I turned this back side just like we did a while ago with that other coaster that's floating around. And I've got 4 pieces of double-sided adhesive on there. And way back when I first started doing this, I bought 1 roll of tape from Woodcraft out here, 2 inches wide. It was about that big around. It's now that big around. Still using it. It's slightly pressure sensitive. By that, when I was taking a class from Lee Carter, he said this stuff's good to use, but you got to be careful with it. When you apply it, you need to put pressure on it for a few minutes to set that adhesive. Otherwise, you're going to have troubles. And that's what we're going to do right now. So I turned the back side, or the bottom side, like I'm using right now, just like we did with that coaster. And I'm going to show you how to do the, I'm not actually going to do it, but I'm going to show you how I use this technique to make that variety of designs that are on the other side. Now, those coasters over there, most of them have inlays in them. And I use this technique to make those inlays. There is a trivet over there that's got fancy grooves cut in it. And Cindy Drozder right now has I think it's this Friday, she has a program where she's going to be showing how to do that type of stuff using the some offset chucks that another vendor has. She's going to show you how to do it. She hasn't done inlays like I'm doing, but she could do it with those things. This is just another way of doing that type of thing. So I want to mount this on there with double-sided tape, but I got to get it centered correctly. So what I do is I take a piece of paper and I draw the pattern that I want, and I mark the center point of each one of those inlays. Here's some others. Okay, so what I can do is, since that's the same size, well, the first thing I got to do is I need to be able to get this thing back on there several times. So I set it here. It's kind of arbitrary, but if you have a preference, you can do that also. But take a pencil, and I've got an index mark right here on my template, and I'm going to make a mark on my blank to line up with that. Okay, so now I want to go in here and I want to line this thing up to make that particular inlay. So I stick it up here. Okay, now that adhesive is starting to stick. That's good. Okay, I'm going to crank that down just a little bit, and that way we'll have some pressure on it to start making that adhesive set. And I'm going to crank the vacuum down on this thing. That's where this isolation valve comes in handy, because I can take that and crank it down and open up my relief valve, and between the two of them I can get fairly good control. And I typically drop it down to about 5, somewhere along in there. Now what I've found is that by doing that, this is loose enough that, let's loosen this up a little bit. Okay, I get that lined up. Okay, and I've got pressure on it as long as I have pressure on it. So I think Lee Carter said about 5 minutes, something like that. Okay, now it's set there, so now I go ahead and set these up to get the maximum vacuum. Okay, and that's disc number 1. I look at my design and say, okay, I've got this. I turned a bunch of inserts ahead of time. And I use a template technique to make the disc for the inserts. I put a piece of block of wood on there. I take a piece of masonite that I turn to exactly 1 1/4 inch, and I hold that up there, and I just like I did for make the outside of this disc. I could make a large number of those 1 1/4 inch discs. Okay, so now I got it set up right. Okay, I pull this out. I take this chuck out, I take this life center out, put it in the chuck with the proper size bit. I come in here and I drill the hole, and I monitor the depth, and I actually measure it, because what I typically do is that the disc itself is a 1/2 inch thick, and I want to have the final coaster 1/4 inch thick, including the inlay. So very carefully drill it down. The inlay is about 1/8 of an inch thick, so I carefully drill it down. And I do not have this surface full 1/2 inch down yet. So I left this kind of coarse. I do that. Okay, I got that finished. Okay, I need to go to number 2. So I drop my vacuum down a little bit again. With the 2 valves, it gives me a whole lot more control over the thing than if I just had the 1 valve by itself. It doesn't have to be exact, but I usually try for around 5. Okay, so now I want to go to disc number 2. Well, I find my index up here. Let's unlock this thing. Find my index, and I go over to disc number 2. Well, that's it right there, isn't it? So I bring this up, and you can either use the step center with the spring loaded, or if you're careful, you can use the center pin of your drill bit. Okay. Get that close, and I've got an indent in the center, so that helps me register it. So now that it's there, I can make sure my index line is lined up and get my little mallet out and okay. I feel it, make sure that I go by touch as much as anything, make sure it feels around. Okay. I've got it ready. I pull this thing out, I put my drill bit back in there, my chuck, and I drill the next hole. And I keep doing that until I get all the way around, get all 4 inlays in there, and the surface texture looks like a mountain range. So it depends upon the thickness of your inlays and such as that. But at this point, I don't care. So then when I get finished, I go back to number 4, which is the center one in this case, and get it centered, and then I can finish the thing off, just like we did with the inside of the coaster without the inlays. And so that's doing the, looks like I got 1 minute. That's doing the inlays like this. You saw some of them are quite complicated, and it makes a difference in the sequence. Now this one, it doesn't make a difference. You have to do number 4 last. If you do it first, you lose it. Everybody else covers it up. But whether you, like one of them over here looks like a star trail. You get one pattern if you go one direction, you get another pattern if you go the opposite direction. Questions? Everybody confused? Well, you can always call me, text me, ask questions. Be glad to help you. Thank you. Did you learn anything? Vacuum chucks are very versatile. It's another tool in your toolbox, allows you to do anything you can think of.